Hello everyone, welcome back. This is part 4 of Unit 1 analysis. In this session, we are going to cover sequence and series of function, uniform convergence, Riemann sum, and Riemann integrable improper integrals. We say Fn converges to F pointwise for all E belong to X. Here for all E belong to X come first, and for all epsilon positive there exists a node such that Fn minus Fa is less than epsilon. And if Fn converges to F uniformly, then for all epsilon positive there exists and not belong to and not depends on epsilon. For all x belong to x, Fn of x minus f of x is less than epsilon. Cauchy criterion, you already know, Fn minus Fn must be less than epsilon for all nm greater than equal to n. Now there are some consequences. If mod Fn of x minus f of x uniformly on E and all Fn's are continuous, then the limit function fx is also continuous. If function is uniformly continuous and if all Fn's are Riemann integrable, then f of x is also Riemann integrable. And limit and integration, finite integration will exchange. All functions are continuous, Fn converges to S, Fn converges uniformly, then Fn dash converges to F dash. Okay. Weierstrass test says if summation of uk be a series of real valued function on a set E, if there exist positive numbers m1, m2, that is summation of mk is less than infinity such that summation of uk is less than summation of mk, then summation of uk converges uniformly on if there is and Mn test. Let Mn equal to LUB, that is supremum of mod of Fn of x minus f of x, and if Mn exists and Fn converges to F uniformly if and only if Mn goes to 0. So here we are talking about sequence Fn. Okay, Fn converges to F uniformly convergence of a sequence we are talking about. Further, let Fn be a differential and assume that Fn dash equal to G uniformly, then that Fn converges uniformly. Let Fn be a differential, assume that there exists f and g such that Fn converges to f, Fn dash converges to g, then f is differential and f dash equal to z. Weierstrass sample, let Fn be a sequence of real valued function. Assume that there exists m positive such that mod of Fn is less than equal to Mn and summation of Mn is convergent, then series Fn is absolutely convergent and uniformly convergent. Dirichlet test. Let Fn and Gn be two sequences of real valued function on X, and let Fn, that is partial sum of f of x, fk of x, assume that Fn is uniformly bounded on X. Second, Gn is a monotonic decreasing to 0 uniformly on X. Then summation of f and Gn is uniformly convergent. So इधर एक का पार्शियल सम बाउंडेड था और दूसरा मोनोटोनिकली डिक्रीजिंग टू 0 था. Abel test, Fn and Gn be the two sequence of real number for summation of Fn is uniformly convergent on X. Second, there exists m positive such that mod of Gn of x is less than m and Gn is monotone, then summation of Fn Gn is uniform. So here also summation of Fn is uniformly convergent and second Gn is monotonic and bounded. एक यूनिफॉर्मली कन्वर्जेंट है, एक सीरीज यूनिफॉर्मली और दूसरा सीक्वेंस मोनोटोनिक एंड बाउंडेड. इन डिरिचलेट इट वाज सम ऑफ पार्शियल सम वाज बाउंडेड एंड Gn is monotonically decreasing to 0. Okay. Abel limit theorem, if the series summation of an converges, then the power series summation of an acceleration converges uniformly on closed interval 0 to 1. Wow. Weierstrass approximation theorem. Let f from closed interval is continuous, and there exists a real polynomial phi of x such that mod of f of x minus p of x is less than. In fact, there exists a sequence polynomial function which converges to f. Let f be a monotone function, then f is Riemann integrable. If f is continuous, then it is Riemann integrable. If it has finitely many discontinuities, then it is Riemann integrable. And if f of x is positive, then integration of f is positive. If f is less than g, integration of f is less than integration of g. And let f be R integrable, then capital F of x equal to integration e to x f of x dx. Then capital F is continuous. If small f is continuous, then capital F is differentiable. Fundamental theorem, integration a to b. In the PDF there is an error, must be continuous there. Integration e to b f of t equal to fp minus fa. Mean value theorem तो पता है, integration e to b f equal to fc into b minus a. If function f from closed interval Riemann a, ओके दो बार हो गया है. If it is Riemann differentiable, theorem generalized. Okay, no problem. Let us consider the function f, that is Dirichlet function is not Riemann integrable. F of x equal to 1 if x belongs to rational, equal to 0 otherwise. Thome function, which is f of x equal to 0 when x belongs to irrational, and it is equal to 1 by q when x equal to p by q is rational. This function is integrable. Mod f, f square, fc, maximum, minimum, all are integrable. Cauchy-Maclaurin integral test. Let f from closed interval 1 to infinity be positive and non-decreasing. Let in non-increasing. Okay, let in is 1 to n f of x and Sn equal to summation k2 to n fk. That is, we are talking about just partial sum. Then the sequence in and Sn both converge or diverge. Wow, here we are talking about sequence. Integral test. It is same like Cauchy integral test. Summation of an converges if improper integration 1 to f of t. That is same as f of an. That is converge. If the summation of diverges and integration does not exist. Next, comparison test. If 0 is less than f of x less than g of x, if integration g of x converges, if the integration g of x converges, then integration f of x converges. If integration f of x diverges, then integration g of x diverges. Limit comparison test. Let f of t is greater than or equal to 0 and g of t is greater than 0 for all x greater than n. If limit extending to infinity f of t upon g of t equal to c, where c is non-zero, then both integral f and integral converge or diverge together. If c equal to 0, then the convergence of integration of g of t implies the convergence of integration of f of t. Okay. Abel test. If integration e to infinity f of x dx converge and phi of x is bounded and monotonic for x greater than integration e to infinity f of x into phi of x convergent. एक इंटीग्रेशन कन्वर्जेंट है एंड दूसरा बाउंडेड एंड मोनोटोनिक है. डिरिचलेट थ्योरम. If f of x is bounded monotonic in the interval, if limit extended to f of x equal to 0, integral f of x dx that integration is bounded. So here f of x bounded monotonic है एंड लिमिट गोज टू 0 है एंड जो phi of x है वो बाउंडेड है. इंटीग्रेशन ऑफ phi of x इज बाउंडेड, देन दोनों का प्रोडक्ट विल बी बाउंडेड. We are having some example of that. cos x अपॉन एक्स स्क्वायर है तो उसको दो में ब्रेक किया, देन वो कन्वर्जेंस सेकेंड वन इज मोनोटोनिकली इंक्रीजिंग। मोनोटोनिक को बाउंडेड होना चाहिए था, इंक्रीजिंग ज़रूरी नहीं है अपने पास, बट ठीक है। ओके सेम सेकेंड क्या है, साइन एक्स अपॉन रूट एक्स है ना, सो वन बाई रूट एक्स और फाइव ऑफ एक्स इज बाउंडेड मोनोटोनिक डिक्रीजिंग। एक बाउंडेड हो गया, मोनोटोनिक भी हो गया। एंड मोड ऑफ इंटीग्रेशन ऑफ sin x is sin x that is bounded finite, and Dirichlet theorem it is also convergent. And proper integral a to b f of x is equal to limit intended to infinity summation h f of a plus rh, where h equal to b minus a by n, and derivative of integration az vz f of x dx integration with respect to z partial derivative with z, it will be integration of partial derivative with z plus f of b of z of z of derivative of b minus f of a of z into derivative of a. These two tests, Abel's and Dirichlet tests, are same like in the case of sequence C, Dirichlet and Abel. There also समेशन ऑफ एफ एन एक कन्वर्ज होना चाहिए, दूसरा बाउंडेड होना चाहिए, एक मोनोटोन होना चाहिए। एफएल के टेस्ट में इधर भी वही है, दूसरा बाउंडेड एंड मोनोटोनिक। एंड द केस ऑफ डिरिचलेट ये से एक यूनिफॉर्मली बाउंडेड होना चाहिए, दूसरा मोनोटोनिकली डिक्रीजिंग होना चाहिए। एंड मॉड एफ एन ऑफ एक्स इज पार्शियल सम बाउंडेड होना चाहिए। एंड इधर देख लो, इधर भी पार्शियल सम बाउंडेड होना चाहिए, दूसरा मोनोटोनिक बाउंडेड एंड गोज टू ज़ीरो। सेम उधर भी गोज टू ज़ीरो था। थैंक यू सो मच।